Hello, this is Sarah Hardy at the University of Maine at Farmington, and this is a video tutorial on how to use R Commander for the situation where you have a numeric response variable and a categorical explanatory variable that has two categories. In other words, you want to compare the means from two different groups. So first of all, you have to open R. So just to refresh your memories, you should have an icon like that if you have it installed on your laptop. And after you open R, you're going to go to Packages, Load Package, and then go down and select R Commander. Okay. And that should pop open an R Commander window. Okay, so the first thing that you want to do is actually get your data in. So just to refresh our memories on that, if you have what you're going to want to do is import data, most likely from an Excel spreadsheet, possibly from a text file for some of the older Macs. I already have my data loaded, and so I'm going to select my data set from here. So if you already have loaded your data once before when you're doing this, you can select your data this way. And I'm looking for my data set from NC State from fall 2000. Okay, so I'm going to start, first of all, by doing some numerical summaries, and I'm going to start by looking at the number of times per week a student eats fast food as my response variable. So, fast food. And I want to look at that by whether students live on and off campus, which that variable I called live. Okay. And so that's going to print for the two different groups, off campus and on campus, the mean, standard deviation, the quartiles, and the sample size. Okay. Next we'll look at making a few graphs, and we'll start with a box plot. And so again, I'm going to select my variable fast food, and I want to plot it by groups. My group is live, so okay, and here is my box plot. Another graph that we didn't talk about in class but is also appropriate for this kind of data is a plot of the means. And so for that one, first of all, we're going to select our factor as our categorical variable, and our response variable is fast food. And it's going to put some error bars on, and we can either select standard error, which is the default, standard deviation, or confidence intervals. So I'm just going to leave it as the default for now. And so, okay. And so what it's going to do is it plots the two means with error bars that go out to the standard errors. Okay, so next I'm going to do my actual hypothesis test. And so to do that, I'm going to go to Statistics, Means, Independent Samples t-test, and my group variable is live. My response variable is fast food. And it's very important to pay attention to which direction the test is going to be in. So this tells me that it's going to be off campus minus on campus. So off campus is group A and on campus is group B. For our alternative hypothesis, we have two choices, either two-sided, which is your not equal to test, a less than test, or a greater than test. So you can select those. We're going to do a two-sided test, so we will leave it up there. We also have to answer the question whether or not to assume equal variances, and the default choice here is no, but how we check that is by looking at the standard deviations. If they're not off by a factor of 2, we can assume equal variances, and so we see here that we have 1.67 for off-campus and 1.91 for on-campus. Those are not off by a factor of 2, so I'm going to hit OK. And this will give you my test, which tells me I have a p-value of 0.43, so I will not reject the null hypothesis. Okay, so let's look at a second test, and this time let's look at, well, first of all I'm going to look at a graph, and this time I want to look at variable how many hours per week students work, and again I'm going to plot it by on and off campus. Okay, and now here's my box plot. One thing to notice here is that we have an outlier. Okay, since our sample size is 31, which is between 15 and 40, if we have an outlier, we should, instead of doing a two-sample t-test, we should do the Wilcox test, which doesn't make any assumptions about the normality of the data. Okay, so that is called a non-parametric test. So we go down here to non-parametric tests, two-sample Wilcox test. Again, our group variable is live, and our response variable is work. Select the hypothesis the same way, and this time, since I think that off-campus students work more than on-campus students, I'm going to select that the difference is greater than 0. And I'll hit OK, and we'll get our results here, and now we can see we have a p-value of 0.003, very small p-value, so we are going to reject the null and conclude that we do have evidence that the off-campus students work more than the on-campus students. And so that is the end of this tutorial.